Hello everyone, welcome to the Renewable Energy Study Group. Basically, in the today's session, we're going to discuss some points regarding the string inverter in the solar power plant. As we know, whenever we are constructing the solar power plant, the inverter plays a very much important role over here. The main and basic function of the inverter is to convert the DC form of the electricity into the AC form of the current over here. After the basic factor, that is DC to AC converter, the inverter also have to plays an important role in the some other function. One by one we're going to see each and every function of the string inverter. So basically when we talk about the string inverter, in this basically when we are connecting the solar panel in the series combination, let's say the 6 solar panel we were connecting in the series combination here, that is a 1 2 3 4 5 and 6 solar panels were connected to series combination, and we call it as a one string we are connecting in the particular solar power plant. So basically the string is nothing but also the row of a solar panels that we were connecting in the series combination over here. So that is why when we are connecting the output of this particular string to the any of the inverter, we call it as this particular inverter as a string inverter. There are basically three types of inverters are there. String inverter is there, central inverter is there, also there is a micro inverter is also there. So basically the particular string or the row of a solar panel we were connecting to the single input of this particular inverter, and thus we call it as this inverter as the string inverter. Most of the cases for the residential use actually we were using the string inverter. Smaller type of a commercial sector solar power plant also we are using the string inverter, and this inverter is called as a string because it is been connected by the 1 2 or max to max the 3 or 4 number of the string is been connected to the inverter. Basically the number of the strings that we are connecting to the inverter is depend upon this particular manufacturer. That particular manufacturer is giving the number of NPPT inputs to the inverter is more, then we can connect the more number of the strings to the individual string inverter. One by one we're going to see regarding this string inverter. The major function of the inverter is that to convert the DC form of the electricity into the AC form, that is direct current into an the alternating form of the current. It will just converting like this. The sinusoidal waveform it is been generating over here. The second important function is to control the maximum power point tracking over here. So basically the maximum power point tracking is nothing but, let's say we are connecting the this 3 number of the solar panel in the string combination or series combination to this particular string inverter over here. So basically if we want to extract the maximum amount of the power from these 3 solar panel that we are connecting in series combination, we have to give the output to the NPPT number 1. NPPT is called as the maximum power point tracking algorithm. Basically this algorithm is set in a such a way that we can track the max to max amount of the V maximum volt and the I maximum current from the individual solar panel, or we can also say the string wise we can extract the maximum voltage and the maximum current over here. So that is why in the lower radiation factor also, whenever we are getting the low radiation from the sun also, so that time also we are getting the max to max amount of power, or try to get the max to max amount of the power with the help of this NPPT algorithm. So basically it depends upon the manufacturer. Like a Polycab, they were giving the 2 number of the NPPT to connect the individual string. Like the Canadian solar inverter, for the 10 kilowatt they were giving the 3 number of the NPPT inputs, so we can connect the 3 strings. So likewise there are various configurations are there actually when we see the data sheet of the particular solar inverter. It depends upon the how many number of the strings we can connect to this particular MPPT. It depends upon the manufacturer data sheet. Whenever we are actually designing the solar power plant, that time we have to focus on this data sheet also. So basically when we see this particular curve over here, the maximum current from the string we are getting is the short circuit current, and maximum voltage we are getting is the open circuit voltage. NPPT algorithm controls and try to get the maximum power point voltage and the maximum power point current from the individual solar panel, or the string wise it will try to get control over here. So this is the next function basically to control the or to capture the max to max amount of a power with the help of this NPPT algorithm. Then the very much important function the grid tie string inverter does is the filtering process, and again the grid synchronizing process. So basically whenever we are connecting the solar inverter typically with the grid, actually we call it as a on grid tie inverter system or on grid solar system, we can say over here. So basically whatever the reference frequency, reference phase and the voltage we are getting from the grid, actually according to that this particular the algorithm which has been set inside this inverter works over here. It sends at which phase the particular electricity is coming, which frequency the particular electricity is coming, and according to that it will try to match the phase of this particular grid to the particular solar inverter over here. Whenever the inverter matches the phase of the inverter with this particular grid, then we can say we can feed the particular electricity to the grid over here, or also we can use the electricity for our powering our home appliances over here. Again in the filtering process, basically whatever the larger harmonics that are present or the harmonic distortions that are present inside the signal, filtering process with the help of this EMI filter, it will just remove these larger harmonics. And also whenever we want to get a smooth sinusoidal curve, actually, so in that case also we require the LCL filters inside this solar inverter over here. So basically instead of working like a DC to AC conversion, inverter has a smart functioning for the NPPT controlling, that is maximum power point tracking, and also the filtering the signal and the phase matching with a grid synchronizing process with the grid that is connecting to the particular string inverter. So basically when we talk about what do you mean by the maximum power point tracking, basically the maximum power point tracking is called as the NPPT technique. The maximum power point tracking is a technique are used to maintain the PV array operating point at its maximum power point. It means that array wise we try to get the maximum voltage and we try to get the maximum current over here and extract the maximum power which is available from the PV array. So we just multiply V into Y, automatically we get max to max power that we can get from the PV array over here. Let's say if I want to track the particular solar panel, actually that time we required either the power optimizer we required, rather we required the micro inverter. So in the micro inverter individual NPPT has been fixed, or the individual NPPT algorithm has been fixed per module wise, per micro inverter wise. So in that cases also we are getting the max to max amount of power or the energy yield at the end of the day, we can say. Now why this NPPT is necessary? Actually the solar module is the limited DC energy supply that we are getting and has an internal impedances that vary throughout the course of the day. So basically when we say, actually it depends upon the solar radiation. In the early morning we are getting the less solar radiation, in the late evening we are getting again the less solar radiation, in between the afternoon actually we are getting some of the higher solar radiation. So basically when we see the graph of energy generation throughout a day, actually it is some kind of the mismatch will be there actually. In the early morning, late evening we are getting the less supply, in the afternoon we are getting the average supply over here. So that is why to track a max to max amount of useful power from the given solar array, that is why we require to fit this particular maximum power point tracking algorithm in the inverter. So basically an inverter without an NPPT circuit, it also working actually, but what amount of power is it extracting from the array, it is somewhat lesser than the NPPT fitted with the inverter actually. So that is why an inverter without an NPPT circuit would result in the subpartial or the non-optimal operating condition between the any PV array of the or particular inverter actually. So that is why we actually required the maximum power point circuitry or the algorithm inside the inverter over here. Unless the inverter can matches the strings to extract the maximum power, the result is a lower efficiency operation for the connected strings actually. The NPPT circuit constantly monitors the array voltages and the current, and it attempts to drive the operating point of the inverter to the maximum power point of the array actually, and resulting the highest energy harvesting for the given solar system. So let's say if you are installing the 10 kilowatt of the solar system actually, and if you are generating almost 17,000 units in the kilowatt hour terms in the annually actually, when we are fitted with this NPPT algorithm, or any inverter is being fitted with the NPPT algorithm over here. And if any kind of an inverter that we are taking for the 10 kilowatt, and if it is not having the NPPT, ultimately the power output that we are getting is reduced up to the 10,000 or up to the 12,000. Also it is drastically decreasing over here in terms of when we match this number of the units has been generated by the particular power plant, and that is why we require to go for the NPPT tracking in the inverter. So basically there are number of the NPPT tracking mechanisms are there. So basically we can say the dual NPPT and the single NPPT we are going to see in this slide actually. Let's say any inverter that we are choosing, if an inverter is having the one NPPT functionality and the other inverter is having the two NPPT functionality over here, then whosoever inverter is having the larger NPPT, we can say it is more beneficial to go for it actually. So let's say to allow the connecting the array with a different solar azimuth angle. Let's say if we are taking the number of the array, if we are taking only one single NPPT inverter, then we have to orient the solar panel in the single azimuth angle, we can say. Because if we are orienting the array in the different solar azimuth, then whatever the power is getting generated from the array number 1 or the string number 1 is somewhat different or the lesser or more than the power is getting from the string number 2nd, and there is a mismatch of a current is happening over here, and which is not good for the life of a solar project actually. And thus if we are going for the different solar orientation of this particular panel, then we have to go for the dual NPPT functionality. Again, if you want to go for different solar tilt angle, it means that row number 1 of a solar panel is having an inclination of the 45 degree, and other row number 2 is having the inclination of, let's say, only 20 degree. If our solar particular rows having the different tilt angle, then we have to go for dual NPPT functionality. And if we are going for the single NPPT functionality, then we have to go for the single tilt angle orientation. Again, if you are orienting the particular solar tilt angle in the different angle, the power output which is captured by the solar panel will be different over here, and that is why we go for the dual or the triple NPPT functionality. Basically allows the connecting array with a different the string length. If a one row is having the 10 solar panel, other row is having the 15 solar panel, then the power output from the two rows are different over here, and that is why we have to go for the dual NPPT functionality. If you are going for the single NPPT, then we have to select the 10 panel for the row number 1 and again the 10 panel for row number 2nd also, because to match the particular current and the particular voltage to avoid the mismatch losses. Again, when we talk about the allowing the connecting strings of the dissimilar module, it means that the row number 1 of a solar panel will having the polycrystalline type of a module, row number 2nd will also have the monocrystalline type of a module, then the power output from the second row is different and the power output from the first row is different actually. Again, there is a mismatch of the current will be there, so that is why we have to choose the same number of a module, like a polycrystalline in the row number 1 and again the polycrystalline will be row number 2nd actually, to get a subsequent same amount of the power from the two rows. And likewise we have to go for the single NPPT if some or the other cases, if it is happen that the two solar panel of the different solar cells if we are using, then we have to go for the dual NPPT functionality. But generally we are taking the same solar panel of a same company and the same number actually when we are connecting the panels in the series combination over here. Again, when we talk about it allows the connection more than two strings without combiner fuses. Whenever we are connecting the two strings, we require the fuse, rather we require the MCB over here to connect the output of these two strings in the parallel combination, and single output we are giving to the NPPT number 1 over here. If we are using the number of the strings in the combination or number of rows in the combination, we require the higher number of the NPPT, rather we require the combiner box to combine the output, then we can go for the single NPPT inverter over here. Again, it provides the better monitoring granularity. It means that array to array we properly monitor that how many amount of the electricity has been generated by the row number 1, how much amount of electricity has been generated by the row number. Second, so array by array and the row by row, actually we can properly monitor that how much amount of electricity in terms of kilowatt hour per day, per month and yearly is getting generated over here. So that is why when we are selecting the inverter, we try to select the inverter of a more MPPT functionalities, that is the dual MPPT or the triple MPPT. When we talk about the data monitoring with the MPPT, actually, then in the single MPPT channel, the inverter can only provide the monitoring data at the entire array level. It means that, let's say this 10 to 20 number of the panel we are connecting, and only the one NPPT will be there for the inverter, then whole array output we have to combine at the combiner box, and again we have to give power to the inverter over here. Whenever our inverter is having only single NPPT channel connection, whether 1, 2 or the 4 number of the strings, data collection will be based on the array level input. So here we don't have the array level monitoring granularity. In short, we can monitor just whole array level over here. But if we have the dual MPPT functionality, we just divide this array into the number of rows over here. We call it as a string over here. So let's say the output of the string number 1 we give to the NPPT number 1. Output of the string number 2 we give to the NPPT number 2 over here. So likewise we have a modular granularity and the more particular power tracking per NPPT wise when we are seeing over here actually. So basically, as a result, there is a finer granularity in the monitoring data, such as the site status, energy production and the troubleshooting data also. It is very important. If any kind of a solar panel is getting shadow, we came to know that row number 1 is having the lower power is getting from the row number 1, so that we can just shut off the particular solar power plant and we do the maintenance of the particular solar panel. This is an important because depending upon the system design and the loading of the two channels can be different. Therefore, for a small system with a one string per NPPT channel, the data collection essentially happens at the string level actually. For a central level, we have a different technology when we are monitoring this particular data. For the larger residential scale system with up to the 2 strings per NPPT channel we can go. It means that let's say the inverter one number of NPPT we divide into the 2 strings actually. It depends upon the again manufacturer, what the manufacturer is giving actually per NPPT basis, how many number of the strings we can connect to the inverter. Second NPPT basis, how many number of the string that we can connect to the individual inverter. In the larger scale of the string inverter, like say the 40 kilowatt of inverter, again the 50 kilowatt of inverter, 30 kilowatt of inverter, there is a more number of the strings we can connect per NPPT basis. Therefore, in addition to provide the proper energy harvest value per channel, the user can understand what is happening actually at each input at any time. This can be helpful in troubleshooting abnormal condition at a given inverter input. Understanding all these aspects of the NPPT can help to provide the better knowledge of how energy harvesting actually works, and therefore helps the solar installation become more profitable in case. So when we talk about the grid synchronizing actually, when the inverter is synchronizing with the grid over here, it will check at which frequency we are getting the particular grid voltage that is coming actually. And as we know, for the particular 20 millisecond, in 20 millisecond we require to complete the 50 cycle of this particular electricity when we are talking about the single phase grid synchronizing. So frequency is nothing but the 1 upon time period. So basically in 20 millisecond, the 50 cycles are required to complete over here. One cycle is nothing but starting from this up to this one sinusoidal wave over here. Simultaneously, same time period and the same cycle has been completed when the inverter is synchronizing with the grid over here. So that is why it will check the particular RMS voltage or the voltage coming from the grid over here. According to the voltage, according to the frequency, it is just try to match the grid synchronizing over here. So basically when we are talking about the phase matching, if the grid is coming with the single phase supply or grid is coming with the 3-phase supply with the RYB or neutral connection, so in that cases actually it will check whether the one cycle is coming in the 20 millisecond of the 50 number of the times. It means that it is the single phase supply is coming from the grid. If the three number of the cycles are coming with a phasor angle of 120, then it will say it is a three-phase supply is coming. And likewise, whatever the supply is coming, let's say this is a grid supply is coming from the grid of a single phase, inverter try to match this particular signal with the grid supply over here. So whenever there is a signal matching is happening with the grid supply and the inverter particular phase supply over here, we are getting at the output level as a good sinusoidal fine wave we are getting, and we can say our inverter has been synchronized with the grid supply or grid phase which is coming actually. Whenever the grid is coming with the sinusoidal supply and the inverter generates the reverse supply over here, then there is a phase matching is not happening over here, and ultimate output we are getting some of the bad waveform over here. That time we are saying the grid supply has not been phased with or in phase with the solar inverter over here. So basically, if any kind of the frequency deviation has been happening at the end of the grid, any kind of the voltage deviation is happening at the end of the grid actually, that time inverter try to shut off all the power getting from the grid actually, and inverter shut this particular system and the solar system will get stopped working when we are talking about the on-grid type of the solar system. If you are going for the hybrid type of solar system, we have the battery supply also. So whenever any kind of the electricity outage is happening, the battery is giving power to the particular appliances. So when we talk about what is the main subsystems has been located inside the string inverter. So the power from the solar panel actually we are giving to this particular solar inverter through the DC disconnect switch. Whenever we want to do a maintenance, we are just either supply the particular MCB we connect, or just shutting off this MCB we can do a maintenance, or simply with a MCB we can also connect the DC disconnect switch. So whenever I do want to maintenance on the DC side or energy emergency shutdown of the solar power plant, that time we can go for the isolator switch or the DC disconnect switch over here. So basically the first step when the power is going to the inverter, it is passed through the EMI filters. So whatever amount of the higher harmonic distortions are there actually, it has been removed by the EMI filters that we are using. Again, due to the lightening or the over voltage which is coming from the solar panel actually, it is when it is passing through this inverter, there is a ground fall interruption devices has been fitted over here. If any kind of the over voltage of current is flowing inside the circuit, it will give the path to direct to the ground over here. So it will protect our inverter for the further damage by introducing the ground fall interruption devices. Further, the power has been given to the DC to DC HF isolation particular converter over here. The main function of the DC to DC converter is that whatever the variable supply of the DC that we are getting actually, because solar radiation is changing from the early morning to the late evening, simultaneously the voltage and the current which is generated in the solar panel is also actually going to get decrease or increase. So ultimately from the solar array we are getting the variable form of the DC supply. DC to DC converter converts the variable form of a DC supply into a particular stable form of the DC supply. With the help of this HF isolation transformer, HF isolation transformer called as the high frequency isolation transformer, basically it will use for step up or step down purposes. In the early morning the voltage is lesser, so just with the help of HS transformer we just increasing the voltage of the stable DC voltage. In the basically whenever there is a higher voltage is there in the afternoon, again with the help of step down we are just converting this particular voltage at a required voltage that we want to give to the DC to AC PWM converter. So basically the transformer, HF transformer we are using for step up or step down purpose as per the voltage which is required to give for subsequent functionalities. Also, the HF transformer provides us the galvanic isolation. Galvanic isolation is nothing but it will isolate the DC circuit from the AC circuit with a ground connection over here. So again any kind of a shock if it is coming in the circuit, again it will protect our circuit from the mismatching between the DC and the AC circuit by providing the galvanic isolation. Inside this DC to DC converter, the 4 IGBT switches are been operating, and thus the stable DC variable DC is been converted into the stable form of the DC supply over here. Again, the power has been given to the capacitor. Capacitors are the DC link electrolytic capacitor we are using over here. When we open the string inverter, we found up to the 20% of the area has been covered by the capacitors only. The main role of capacitor is what? It will store the requisite voltage or the requisite power for a short span of a time, because whenever we required the DC to AC conversion into the PWM converter, we required to give uninterruptible form of the DC supply to this particular DC to AC converter. So that is why to give uninterruptible supply of the stable DC voltage, we require the DC link electrolytic bulk capacitor we required over here. Again, when we are giving power from the capacitor to up to the DC to AC PWM converter, it is a pulse width modulated converter we are using. Here again we are using the 4 number of IGBT switch. So here the DC form of the electricity is been converted into the AC form of the electricity over here. So basically whatever amount of signal strength is there, it is some kind of the harmonics has been located in this particular sinusoidal waveform which has been generated by the DC to AC PWM converter. Again, when we are giving this power to the AC line filter, which are also called as the LCL filter we are using, the major role of the LCL filter is nothing but to filter this particular harmonics contained inside this sinusoidal wave, and ultimately at the output level we get the fine form of the sinusoidal wave, so that we can match this particular grid frequency or the grid phase which is coming over here actually. And that's to require or to remove this particular harmonics, we require to connect the LCL filter over here. Again, this power we are giving through the DCDB to this particular grid. So likewise the inverter is working. Nowadays basically there are number of the functionalities are coming in the inverter actually, like the digital control we can do, like the remote monitoring operation also we can do in the inverter over here. In the respect to communication also, whatever amount of power is getting generated per day wise, month wise, it has been monitored by the inverter also. So basically the algorithm, that is a MPPT algorithm, has been fitted with this DC to DC converter over here. So as per this number of algorithm that we are using, or the number of circuitries of the NPPT that we are using, it will decide how many the NPPT in the inverter is providing over here actually. And it depends upon the manufacturer, how he is manufacturing this particular inverter and how he is giving the NPPT input functionalities over here. Fine, thank you for the watching the video. Fine, share this video to your friends also and learn more about this solar energy also. Thank you for the watching.